Hello, everyone. Good afternoon, and welcome to our webinar today. And my name is Mukta Naik. I'm a fellow here at the Sustainable Futures Collaborative, and very proud to introduce the first webinar that is in the coastal management and adaptation space. A little bit about SFC before I introduce my esteemed panelists today. SFC is a Delhi-based independent research organization. We work on climate change, energy, and the environment. We do research which focuses on systemic changes, and we focus on policy levers, mostly mid to long-term policy levers. And our objective is to help India transition to a sustainable, just, and resilient economy and society. Soni and me, Dr. Soni, who will present today, and me belong to the adaptation and resilience vertical within SFC. This is a growing vertical. We are now focusing on heat, coasts, as well as forests, and we hope to expand. And our view has been to look closely at governance institutions and processes, as you will hear more today from Soni. Today's webinar is based on an issue brief that Dr. Soni and Skandita, who also works with us, have prepared, which lays out the sort of rudimentary ideas behind a multi-hazards framework for coastal management. To give us inputs about our work and to take this subject to all of you and to discuss it in a broader context, we have three extremely qualified and well-spoken experts with us today who come from very different walks of life. And we're very, very happy that you could join us today. Dr. Parsarthi Roy is a senior ecologist and a leading Earth observation scientist. He specializes in remote sensing and geoinformatics with a focus on biodiversity, climate science, disaster mitigation, and natural resource management, and spent many years at ISRO. He retired as the director of the Indian Institute of Remote Sensing. Welcome, sir. Very happy that you could join us today. Dr. Krishna Malakar is an ecological economist, and she's faculty at the Department of Humanities and Social Sciences at IIT Madras. She's interested in the human dimensions of climate and environmental change, adaptation, vulnerability, resilience, and sustainability. Thank you, Dr. Malakar, for being here with us. And Dr. Johnson Jement is a research fellow with the School of Global Studies and Sussex Sustainability Research Program at the University of Sussex in UK. He also leads Blue Green Coastal Resources, which is a social enterprise in India focused on indigenous and local knowledge-based research and community development initiatives. Thank you, Johnson, for joining us and for adding that very valuable perspective. We'd welcome all of you from everywhere, all across India and other time zones who are with us today. And we encourage you to engage with with what we're discussing today and post your questions in the Q&A box so that we can bring you into the conversation at an appropriate time. And with that, let me hand over to Dr. Soni, whose work he will be presenting today. And if you could give us an introductory sort of pitch on the work that you've done and how you're framing coastal management from a multi-hazards perspective. Over to you, Sonny.
Thank you, Dr. Mukta. Let me just share my screen first. Oh, the screen is visible?
Yes, please go ahead.
Okay, thank you once again, and good evening, everyone, and thank you for joining us. Before I begin, Mukta has already mentioned that this presentation is based on an issue brief we released in March 2026 titled Strengthening Coastal Resilience in India, a multi-hazard approach to adaptation governance, which was co-authored by Skandita Tiwari and myself. So today, my objective is not to provide all the answers, but to set the context for the panel discussion that follows. Basically, how India's coastal risk landscape is changing, why this presents new governance challenges, and why a multi-hazard approach deserves greater attention. The central message is simple. Coastal risks are becoming increasingly interconnected, but our governance systems continue to plan and invest largely hazard by hazard, single hazard. And bridging that gap is essential to build long-term coastal resilience. Before discussing coastal hazards and the need for a multi-hazard approach for adaptation, it's worth reminding ourselves why India's coast matters. India has a coastline over 1,100 kilometers, stretching across 9 states and 4 union territories. It supports some of the country's most valuable ecosystems, such as mangroves, wetlands, and estuaries, while underpinning fisheries, ports, tourism, and the rapidly growing blue economy. More than 250 million people lives within 50 kilometers of the shoreline, and millions more people depend on coastal resources for their livelihoods. So coastal adaptation is far more than an environmental issue or a biophysical issue. It is about protecting people, livelihoods, infrastructure, and the ecosystem that support economic development. So, what is changing? The coastal landscape is being shaped by two broad sets of drivers. The first is climate change, rising sea levels, changing cyclone intensity and storm surges, more intense rainfall, and so on. The second is rapid coastal development, urbanization, land use change, population growth, groundwater extraction, all of which increase exposure and vulnerability. Importantly, these drivers don't operate independently. Climate change is increasing the intensity of hazards, while development is placing more people, infrastructure, and economic assets in harm's way, in the way of the impact. It is this interaction between climatic and development pressures that is fundamentally reshaping coastal risk in India. To understand this changing risk landscape, I focus on five major hazards: cyclones and storm surges, coastal flooding, sea level rise, and coastal erosion, and finally, saltwater intrusion. So these can be categorized into two broad categories, which are acute hazards such as cyclones and flooding, which produce immediate impact, and chronic hazards, which include sea level rise, erosion, and saltwater intrusion, whose effects accumulate gradually. So we selected these five because they are among the most frequent and damaging along India's coastline. And more critically, because each is typically managed through a separate institution or program, as we will see, that sectoral approach becomes a real problem because these hazards don't occur independently. And the evidence shows these hazards are intensifying, not just staying flat as it is over the years. Cyclones continue to cause major impact on the East Coast with rising severity and frequency, which is now observed on the West Coast. Earlier, we thought that it is only focused on the East Coast. India saw 27 cyclones between 2019 and 2024, and four of them are very severe, impacting the lives and livelihood of people. Coastal flooding is becoming more frequent with rising sea levels and more intense rainfall. About a third of India's coastline was under erosion in the 1990 and 2018 assessment. Sea level rise is accelerating and saltwater intrusion is expanding across coastal and deltaic systems. The point isn't any one statistics, it is that every one of these hazards is intensifying at the same time. Just to ground that last point, which I mentioned in the data, on the left of the slide, you see high tide flooding days in the Indian exclusive economic zone have been climbing since 1979. On the right, shoreline status by state, you can see West Bengal and Pondicherry already have more than half of their coastline under erosion. This is the physical evidence behind the trends we just mentioned. So this brings me to the central argument of this presentation. So far, we have looked at these hazards individually. In reality, they rarely occur in isolation. They interact, cascade, that one trigger the other one, or compound, that is the impact of multiple hazards comes together and having a larger impact. And this is happening over time. So as this diagram on the right side of the slide shows, sea level rise acts as an underlying driver, which intensifies storm surges during cyclones, deepens coastal flooding, and accelerate erosion by letting waves reach further inland. Each of these, in turn, weakens natural and built defenses, increasing exposure to the next event, and repeated flooding and storm surges drive saltwater intrusion into freshwater systems. This is already visible in India. It's not that we only talk this in modeling and theoretical terms. In Mumbai, for example, Heavy rainfall during high tide produces far greater flooding impact than either factor alone would have created. In the Sundarbans, cyclones such as Amphan and Yas didn't just cause flooding, they triggered long term saltwater intrusion and degraded agricultural land for years afterward. The implication is our risks are no longer hazard specific, but our governance and programs remain largely organized around sectoral programs and independent hazard management. That mismatch between how risk actually behaves and how we govern it is the core problem of this presentation. So how does India currently respond to these multiple hazards? On the regulatory side, we have the CRZ notification, the Coastal Zone Regulation, Coastal Regulations on Notification of 2019, and we have Coastal Zone Management Plans, which is coming out of the CRZ mandate. And we have allied laws like the Environmental Protection Act, Wildlife Protection Act, Forest Conservation Act, Biodiversity Act, and so on. On the implementation side, we have hard and soft engineering approaches, nature-based adaptation or nature-based solutions, and the integrated zone management program. On paper, this is a fairly comprehensive toolbox. The challenge is not about the toolbox, it is how the tools are used. Most continue to operate through a single hazard logic. And to understand why this is continuing to operate in a single hazard logic, we need to look at the institutional landscape itself. And that landscape is crowded, very much crowded, as you can see in the slide. The Ministry of Environment, Forest and Climate Change leads regulation and ecosystem oversight. The Ministry of Earth Sciences handles ocean science and early warning systems. Ministry of Jal Shakti, on the other hand, manages flood and coastal protection work. Ports and shipping drives coastal infrastructure related to ports. Home Affairs on disaster management. And on the ground, it is the states through their coastal zone management authorities and line department that actually implement all this. So this distribution makes sense since coastal issues are inherently multidisciplinary. But each institution largely operates within its own mandate, and coordination across sectors remain limited. The result isn't an absence of institution, but it is a lack of integration between them. This is reflected in the policy record too. This chart plots the major coastal acts and policies that India has passed from Indian Ports Act in 1908 through to the 2023 multi-hazard early warning systems and the Mishti mangrove initiatives. What stands out is the spread. Decades of policy oriented towards coastal management and operations, with the center of gravity only shifting toward climate adaptation and resilience in the last few years. You will see certain plans and policies related to that. India, in that sense, does not lack policies for coastal adaptation and resilience. It lacks a policy history that was built with compounding multi-hazard coastal risks in mind from the outset. So where do the practical challenges arise? So I want to highlight three challenges here. First, coastal governance remains largely reactive. Disaster responses often takes precedence over long-term adaptation. And you can see this in the numbers. For example, the National Coastal Mission, which is supposed to be coordinating various activities of coastal-related development and conservation, the budget was cut from 195 crore rupees to 50 crores between 2022 and 2024. Second, the implementation is uneven. Coastal zone management plan compliance varies considerably across states. For example, under the CRZ, every state should be preparing coastal zone management plans or CMPs, but we see only few states preparing the CCMBs, but there are most of the states have prepared the coastal zone management maps and by delineating the areas where CRZ law is applicable. And there are a lot of issues, especially from the CAG reports and so on, about the non-compliance of CRZ, which is persisting, where even though we have strong rules exist there. The third point is overlapping mandates and competing priorities limit coordination. Infrastructure or port development schemes don't always align with ecosystem restoration or resilience objectives. Together, these reinforce the governance mismatch I described earlier. That is, risks are interconnected, but planning stays within the sectoral boundaries. To give a concrete example, we know about the Sagarmala program, which is by the Ministry of Ports, Shipping and Waterways, which contradicts a nearby mangrove restoration effort driven by MOFCC. Likewise, National Cyclone Risk Mitigation Project, which is NCRNP, under Ministry of Housing and Urban Affairs, conflict with uncoordinated erosion schemes under Ministry of Jal Shakti, fragmenting a holistic coastal resilience approach. Uh, One consequences of this is continued reliance on hard engineering as the default response. Seawalls, groins, and tetrapods offer a visible, immediate protection, and they will remain necessary in many high-risk areas. But coastal systems are dynamic, and these structures can disrupt sediment transport. And if it planned in isolation, they often just transfer erosion to the next stretch of the coast rather than solving it. In effect, it's creating maladaptation. A lot of this comes down to the planning at the site scale, basically at the protecting one settlement or one area of the coast where is maximum issues happening, rather than the larger scale, which is a sediment cell scale, which is a scale at which coastal sediments actually move. So that means you need to have, engineering structures of a longer structure of longer stretch of space than the immediate hazard impact areas. So the issue is not engineering itself; it is engineering without a systems perspective. So this chart reinforces that point with the spending data itself. You can see state-wise expenditure on coastal erosion and saltwater intrusion projects across almost every state for both hazards. Hard structures dominate the spend, often overwhelmingly so. The spending patterns suggest a strong emphasis on structural protection with comparatively less investment in layered adaptation approaches. So alongside engineering, nature-based adaptation like mangrove restoration, dune conservation, coastal vegetation, all of them have emerged as an important complement. It can reduce coastal risk while delivering core benefit like biodiversity and livelihood support, but it is not a universal solution. Its effectiveness depends on local ecological conditions, land availability, and long-term maintenance. And in some dense urban coastlines, engineered protection will often remain necessary. So the key message is that this isn't engineering versus nature-based solutions or nature-based adaptation. It is the need for a layered adaptation, combining both according to the local conditions and risk profiles. If integration is the key to resilience, India already has a framework designed to deliver it, which is Integrated Coastal Zone Management or ICZM, which was conceived to align conservation, development, and risk reduction within a single planning framework. And it has contributed meaningfully to coastal mapping, hazard assessment, and capacity building. But its potential has not been fully realized. So implementation has stayed largely project-based. You can see the first phase, which was in Gujarat, Odisha, and West Bengal, which is piloted in only these states. And with there are lack of compliances like hazard lines not fully operationalized or integrated management plans for critical vulnerable areas are not present, and such multiple issues of compliance related issues of ICCM. So the challenge is not creating a, it is strengthening and operationalizing the one we already have, and that could be an ICCM framework. So one thing which brings together the ICCM and the engineering measures and NBS, which I earlier mentioned, could be a multi-hazard approach to adaptation. So what would a genuine multi-hazard approach actually enable? So here I just want to mention that this is a thought about a multi-hazard approach, and there are like different kind of efforts are coming from different side, and you see a lot of literature coming from other part of the world as well. So for us, it means explicitly accounting for how hazards interact and compound rather than assessing them in isolation. It means integrated risk assessment that combine physical, ecological, and socioeconomic vulnerability. It also means aligning planning, budgeting, and decision rules across sectors instead of each sector operating through a separate planning process. For a multi-hazard approach to adaptation, it is also important to sharing infrastructure and data, hazard lines, monitoring, forecast, and so on, rather than duplicating them. And it means deliberately layering engineered and nature-based adaptation rather than treating them as competing choices. In short, it shifts the focus from responding to individual hazards to governing the cost as one of the complex, interconnected socio-ecological system. So let me close with 3 points. First, India's coastal risk landscape is changing. Climate change and rapid development are increasing not just the intensity of hazards, but the complexity of the risks they create together. Second, these hazards no longer occur in isolation. They interact, creating cascading and compounding impact that our current planning and governance methods are not designed to deal with these interacting risks. Third, our governance systems need to evolve accordingly. India already has the institutions, policies, and framework it needs. The task now is to integrate them through a multi-hazard approach built on coordinated decision making, systems thinking, and layered adaptation. Stop there. Thank you all for your attention, and I'll hand back to Dr. Mukta, who will moderate expert responses and discussion for our panel. Thank you.
Thank you so much, Soni. That was amazingly well on time, I have to say. So thank you for that. In this first round, to all three panelists, I would request you, I mean, this webinar, the selfish motive of SFC in doing this webinar is to really get really incisive and, sharp comments on our work and how we've positioned the issue. So in this first round, if you could just quickly respond to the brief itself and what Soni has just presented and whatever your first thoughts are from your various perspectives. So I could maybe start with Professor Roy. You'll have to unmute yourself.
So thank you, Mukta. I think the Mr. Dr. Soni, what he has done as a very comprehensive issue brief, and I personally feel it's an important and timely argument he's putting forth. At the moment, I fully appreciate that concern being shown here that Indian coasts are being managed in isolation through separate responses on cyclone, flooding, and erosion, sea level rise. Now, these ones and are handled by different kind of players, which Dr. Soni has highlighted. I just wanted to focus from the geospatial and landscape perspective. Couple of points. First thing is multi-hazard maps, which is basically generated is simply by overlaying the individual hazard maps, which we must understand how hazards interact. Sea level rises the baseline water levels, cyclones, stroke surges create acute shocks. Erosion weakens coastal protection. Repeated inundation increases soil and groundwater salinity. And to capture spatially, we must uh, inter and ensure that interlinkages are established. So, because each one has got a cascading effect, at the moment, I see that this is a major gap in uh, creating in the geospatial and uh, multi-hazard landscape. The second point which I would like to make is a basically hazards alone. It depends on the ecosystem, kind of vulnerability, and adapting capacity. Now, the impact of same cyclone will be different in different kind of a ecosystems landscape. Hence, uh, this difference has to be included in uh, when you determining the hazards of the in multi-hazard environment. like the impact of a same cyclone will be greatly different in the mangrove uh, fringed deltas, eroding fishing villages, densely populated cities, or industrial coastal towns like Vizag and therefore, physical hazard data must be integrated with the information on ecosystems, land use pattern of something like uh, a 1 is to 10,000 scale, which is with the, provides uh, a clear guidelines to what kind of a land use exists and what kind of a land use is exposed. And finally, I would also try to include infrastructure updating information and population, their livelihood systems, and social vulnerability. Now, these data sets at the moment is very weakly linked to the geospatial and landscape. I think I will stop here and listen to more comments from the other speakers. Thank you.
Thank you. Thank you very much, Professor Roy. Professor Dr. Malakar, can we move to you next?
Yes, thank you, Dr. Mukta. First of all, I would like to congratulate Dr. Soni and his colleague for bringing out this brief, very important and timely and relevant brief. First few thought is, yes, I completely agree with the brief. I mean, we need to focus on multi-hazards. There are very a lot of misalignments among the governance verticals. Talking about multi-hazard, I believe since I'm an ecological economist, I come from a humanities background. I believe that biophysical hazard data is a lot better than what we have regarding the socio-economic, what we have data on socio-economic characteristics. I'll be presenting a very small snapshot of my paper that Dr. Soni has referred to. So there we have so he has highlighted that it is very important to integrate socio-economic characteristics with hazard data to understand risk. This is what IPCC also tells us. Risk does not only come from hazard. As Professor Roy told right now, that based on the socio-economic characteristics of communities, people may be affected by the same hazard differently. However, to have these kind of risk assessments where we combine everything, I believe that in a country like India, we have kind of okay hazard data, but the socio-economic data quality is very poor. The last socio-economic, so in my paper, for example, I source the socio-economic data from the census. We have NSSO data which are collected, but it's not country level. It's very difficult to extend it to the district level. So risk assessments should be dynamic. That's what my point is. It should not be at one point of time only. Risk changes with changes in hazards, because we are in a dynamic environment, because of climate change, because of development policies too. The socioeconomic characteristics of our districts uh, are changing a lot. So until and unless we have access to dynamic data, which gives us access to dynamic risk assessments, it is difficult to have a governance system which will be on point. We may be focusing on issues which may not be relevant at that point of time because the data is old. So we have to probably think in that direction also, um, uh, um, uh, constantly keeping up to date with the data. That is what many global north countries are already doing. Or their projections are so strong, they have teams which will project socio-economic information as well, just like we project hazard information right now. I think IMD, IITM, ISRO is quite good in making projections. We have a lot of publications, but we are kind of short in terms of what is happening with the socio-economic data. And the second point, I'll keep it brief. Dr. Soni emphasized that there is, not convergence among the governance structures, right? Somebody is doing something else, the other ministry would be doing something else. And this is a pertinent problem which is there in every sector in India. I think in India we have a lot of nice rules and laws, but it's the problem is implementation. And before implementation, probably we have to focus on alignment across the verticals and also horizontally. So I think I'll end with that. Over to you, Dr. Mukta.
Thank you so much. Absolutely. I mean, I'll push you a little bit more when you're in round two on, your first point about socioeconomic data, lack of or weakness of it, and the concept of multi-hazards approach, which also is, there are two complexities there that we're dealing with, but we'll come back to that. Can I ask Dr. Jement to come in, please, at this point?
Hi, thanks, esteemed professors and others. It's very important. It's a very nice webinar. Actually, you are attending very important issue, actually. So I have three points related to what we have already mentioned, including what Sony has mentioned. We are talking about socio-economic and other biophysical data. I will also add one layer, biocultural data. So it's very, very, very important. I'm talking about community perspectives. What biocultural data meaning is also it also depends on how much we know about coastal communities, especially indigenous peoples and fish and ocean dependent communities. So you talk about the hazards actually experienced by different people differently. So in that sense, how these hazards are actually experienced by indigenous people and other coastal communities, that's very important. There, I sense to feel that we are focusing more on the physical health of the person or physical, issues caused by these hazards. But we also need to look at mental health as well, which is very, very important. So people, especially when they build a long-term relationship, long-standing relationship with the ocean, they have developed a different resilient capacity. So this also developed their different capabilities also there that also need to look at. That's one point. Second point in Sony's presentation, again, yes, you did very well. The usual, existing scenarios we will explain very well. So one key aspect often missing in our climate change dialogue is the sea perspectives. Sea perspectives in the sense that it's more like I see this as a kind of more like a land-based thinking. But what we need is more like an ocean-based thinking, the sea-based thinking. So there, one component is particularly very important in Indian context, which is weakening monsoon system. So now people are started to think about it. So you're talking about people talk about generally, the high winds, storms, etc. But at the same time, there is no strong winds. That is the issue for many coastal communities. You talk about cyclone. Cyclone is 2 to 4 days impact generally. Or if you look at, from the perspective of the coastal or the ocean perspective. But if you look at the southwest monsoon is a 2 to 4 months. It's a sea condition. People often talk about the southwest monsoon in terms of the rainfall, but actually it's a sea condition. There are a lot of things are happening during the southwest monsoon at sea. So that's why I mentioned it's a sea-based perspective is largely missing. That we can discuss that later, maybe more in depth. That's my second point. Third point, I think Sony also mentioned this engineering solutions. Yes, engineering solutions are very important. So the one comment about this is not what about engineering solutions are not done well, but I have a very, very specific perspective on that because it's not about engineering solutions. I often see that engineering solutions are not done with ocean science. And the ocean science meaning trustworthy, accurate ocean science. There comes the ocean science is not that science actually, with the institutions or with mainstream scientists. It's also the science with the communities. So we look at the community science as well. If you're thinking about multi-hazard approach, so you need to think about the whole design of science as well. The community science with institutional science. That angle also you need to look at. I'll stop there. Thank you.
Thank you so much. That was it was a really fascinating perspectives, especially the sea-based perspective, which I hadn't really thought of that in that way. So thank you so much for bringing that in. Sony, before we get into round two, do you have any quick responses that you want to make to anything that was said? Since I'm giving you a chance to defend if you need to
No,
defend.
no, thanks, Dr. Mukta. And I think Professor Parth, Savitri, Ravi, and Malakar mentioned rightly about kind of aligning our own thinking. And I really kind of recognize what Dr. Johnson mentioned, because the thinking from an ocean perspective and somebody being more think about the wet ontological spaces, which is the conceptual category emerging now, which I think that's more important. And that is we even though when we spoke about cost as an kind of interspace between the sea and the land, our focus has been towards the land. Maybe that we live in the other side, and I think that is something we would think more deeper and then will bring when the due course of the time. Thanks very much for the comments.
Thank you, Sony. So we're moving on to round two, and in round two, our ulterior motive is to really push this idea of adaptive governance and as it applies to the coast. So again, I'll go in the same order, and I'll start with Professor Roy. If we are to really have a much more responsive, multi-hazard, like you said, use technology, especially geospatial intelligence, to not just deal with multi-hazard, but as you said, to layer many of these realities. How would we need to shift the governance response or mechanisms or institutions to actually be able to do that? You've had a long career, and I'm sure you have some insights on what we could do, what is already happening, or what are really like low-hanging fruits in this area.
Thank you, Mukta. I think very interesting comments have been made. I really appreciate the comments made by Krishna and Dr. Johnson uh, on the presentation. So basically, I think we all agree that Dr. Soni has been able to capture most of the issues concerning to multi-hazards. Again, coming back to my specialization in the GIS landscape and spatial analysis, uh, presently the uh, GIS and spatial data, which is data sets which are being generated, they are being primarily focused to map generation and layering of the information, taking this information based on the administrative agency, administrative framework, that kind of. But I think from this Sony's presentation and the two panelists has very clearly said that it is not at the moment integrated data set which should deliver a kind of the has multi-hazard connecting hazards. It will. It has not incorporated so much ecosystem information, the land use information of high granularity which is required. It is also not inclusive communities, the communities practices, uh, the infrastructure which is very dynamic, and it is not properly reflected in the data sets. Uh, I fully make a case that coastal landscape is very, very dynamic, and the kind of a dynamism is there in the ground level. They are not being captured in the spatial data set which is available. And lastly, what Johnson has very this thing ocean perspective and future climate scenarios, they are not taken into account to detailed presentation on the multi-hazard scenario. So basically, our central challenge is how to migrate to the a system which includes the satellite data derived information, include the timeliness, the temporal part of it, ocean observation systems, especially the points which Dr. Johnson has mentioned, the meteorological aspects, the weather forecast in the coastal and land and coastal environment, and finally the micro disasters which is taking place, which are not coming into daily perspective on building up, like erosion, the degradation of soil, the increasing in the groundwater salinity. These are invisible hazards which are creeping in the system. So, real challenge is dispersed across the institutions, and often they are isolated technical inputs, publications, and each publication, they are of great value, but they are not coming out as a technical strong input with the integrated perspective. Uh, for achieving this kind of a scenario, I recommend a couple of things. First thing is, the uh, data sets which are being generated, they are organization specific. Based on the specialization of the organization, they are produced, they are very comprehensively designed, and I do not say that they are not complete from the requirement point of view. However, there is a two aspects we need to be. First thing is, we should provide a institutional ownership and credibility of data generation. Now, once you have the institutional credibility, ownership, then people will come and integrate the data set in such a form which will be, provide a integrated perspective. Often I have seen that you build a individual specific data sets, but they do not talk to each other, or they not meet the requirement of the stakeholder at a ground level. So my this will be a first point which need to be considered in designing a multi-hazard scenario. The second is uh, a distributed system which is largely federated. I'm not saying that it should be a centralized data, but it should be a federated data set through build up a kind of a protocol where each data sets are talking to each other, following interoperabilities, and also take care of the zooming in and zooming down capacities. Now, this is very greatly challenged system. One should have a kind of if you want to design this, there should be a platform to discuss this and design such platform which is gives a solution from different granularity. Meteorology, ocean parameters, these are of different granularity. If you take ecosystem approaches, they are in different granularity. If you get into a implementation level, you need a different kind of granularity. So you need to create this data set, but at least you should be able to zoom in, zoom out. It is my feeling that coastal systems, if you take the coastal zone maps which have been prepared, they are remained as a static map. And land use map, they are also very, very static. They are not updated at a regular interval. They have a very time this thing delay in updating. There should be a regular frequency on which they are, and this frequency is depend on the kind of a landscape which we have. Very rightly, Dr. Soni has divided the landscape in different perspective point of view, especially kind of a landscape and ecosystem exists. So the dynamic component has to be built in what kind of a updating is required. Today, fortunately, we have a very good system of creating a data sets and a very high resolution to the coarse resolution. We also have satellite systems which provide a very good meteorological information. Our meteorological services have improved drastically. But again, the issue is they don't talk to each other. At the moment, they are in isolation. So we have to replace the static map to the dynamic. The dynamism is again varying. The ocean parameter varies, and meteorology has varies in different temporal domain, whereas land use and other infrastructure, they in different domains. Now, how we should align our planning? I don't think there has been any change. So far, most of these hazard maps are prepared in administrative blockwise because implementation is done in the administrative blocks. So this particular approach need to be changed. There should be a kind of a approach which takes into landscape approach in preparing the, because like suppose scale of lands, sediment cells, estuaries, deltas, watersheds, coastal landscape, they are varying. They you have to treat them as a separate landscapes and then create hazard maps. Over that, you can overlay administrative boundaries mainly for implementation. But hazard assessment has to be done landscape and ecosystem basis. The Presently, the geospatial risk information is at a ground level in the lack of required data set. In the lack of required data set, there is a data set, but required data set mostly work on common sense, and they are administratively designed with a past experience common sense approach. I am very clear on my past experiences. Hence, the if you want to build a scientific and foolproof system for a multi-hazard ecosystem, you need to build a risk information mandatory for decision, and you should have a kind of a data set which addresses all the requirements. It passes through the requirement and different scales. You should answer the question whether intervention reduces one hazard but increases another. It actually, Dr. Soni has mentioned whether it transfer risk to the adjacent area and how it affects the ecosystem livelihood. I think I will close in this with my comments on this. Thank you.
Thank you so much. Those were really comprehensive. So thank you. It covered a lot in terms of scale and also new questions about, the difference between having technical data and actually administer or using that data for implementation. Very grateful to you, sir. Can we have Dr. Malakar come in? I believe she has a short presentation which will illustrate the point
Yeah.
she earlier made in her first intervention. I would also, while you're putting up the presentation, please go ahead, ma'am, to do that. Sort of draw attention to the panelists and the attendees that there are a number of questions in the Q&A box that are further animating these discussions, bringing in many, many interesting perspectives and reactions. So I'd urge you to take a glance at that, and we'll try and answer as many as possible. Over to you, Dr. Malakar.
Yes, thank you, Dr. Mukta. So I'll just be presenting some glimpse of my work that I have been doing in coastal regions to make my point that risk assessment is important, understanding socioeconomic vulnerability is important. So I would like to reiterate that our coastal region is vulnerable to multiple hazards. We have a very long coastline, which makes it very, very important that we work on, adapting to climate change in our coastal regions and by coastal communities. So this is some evidence that that we have from our research paper that was published quite a few years ago. So we assess the risk along all the coastal districts of India. So this is the final result. The map on the right, you can see that these are the final results. You can see that most of the districts in the eastern coast is of course riskier than the west. Now, what do I mean when I say risk? So according to IPCC, risk is a function of hazards, vulnerability, and exposure. Hazards come from the biophysical factors such as cyclones, tidal waves, sea level rise, and vulnerability comes from the socioeconomic characteristics. So we try to operationalize these framework given by IPCC. By the way, before this framework is from the IPCC AR5 assessment report 5. Before that, there was nothing called risk according to IPCC. They used the term risk in their literature, but they didn't define risk. They emphasized on understanding vulnerability rather than risk, and vulnerability was defined in a different manner. But this is how they updated it in AR5. So we had different components of hazard. We tried to focus on multi-hazards. We considered data on cyclones, storm surge, tides, precipitation. So some of this data was already available in different government portals, and some of it we could, we had the raw data and we, analyzed, and we got some information and we used it as an indicator. And similarly for vulnerability and exposure too, we had a number of variables. I won't go into that, but most of it was again sourced from government websites and places like census, economic survey reports of different districts, etc. So this was the results. We did an assessment of risk so this work was done in 2018. So we assessed risk for the year 2011 and also 10 years back, that is 2001. And what has been the changes? We found that in some of the regions, so the last panel, panel C, shows the change in risk, whether risk has increased or decreased. On the eastern coast, unfortunately, the risk has apparently increased in one decade, and on the western coast, however, the risk has decreased. This is mostly because the hazards have also decreased in some of the regions. We have more intensify. So according to the data of 2011, that's what I'm saying. This is old data. This is from 2011. So we don't know what the current status is. I haven't worked on it and I haven't come across a similar work which I can relate to, or through which I can make a comparison. So we found that hazards have little bit decreased on the western coast. The intensity of cyclones have increased in the east. However, in some districts, many of the hazards have decreased. Intensity has decreased. Vulnerability. So in many western districts, vulnerability has actually decreased. So there has been a lot of socioeconomic development in the past one decade. So we could find that vulnerability has actually decreased in many of the western regions, but again, in the eastern region, vulnerability had decreased. So the combined effect of all these factors led to the first risk assessment map that I had shown you in the beginning. So this brings us to the point that why vulnerability matters, why socioeconomic vulnerability matters. So Sony has also emphasized the fact, Professor Roy too, that even if districts are exposed to the same hazard because of different socioeconomic characteristics, these districts can have varied risk. So this is one example again. So this was the first work that I showed was based on secondary data. Here actually we did some primary survey to understand. So I'm talking about this survey to make you understand how social vulnerability matters. For example, in this, so we conducted a survey of 1,000 plus fishermen in Tamil Nadu, and we wanted to understand how people perceive early warning systems. Warnings given through early apps and early warning systems to fishermen to not go and fish. So apparently there are a lot of sources of information, but the fishermen trust only their community members or cooperatives when it comes to all these warnings. So lot of agencies like Incois have actually given them apps where they can check the weather, where they can check whether to go out to the sea or not today. But these apps, even though it is easy to use and there is a lot of trustable information, but somehow the community doesn't trust. So factors like building trust, factors like having good governance where people can where people think they can depend on, also matters for good adaptation or sustainable adaptation, right? So this is what is the last mile paradox. Even though we have a lot of weather information, there are only some weather information which actually is implemented or responded to by these vulnerable communities. So risk assessment should include all kind of vulnerability, social vulnerability, economic vulnerability, apart from multi-hazard risk. And so I want to make another point regarding recovery. So now first I talked about analyzing risk. Second, I said that if we know what is the risk, how do we communicate? So in case of communication, one of the barriers is trust. And now suppose if people do not respond to warnings and they actually experience the extreme event, what happens? What factors drive their recovery after they experience the event. So again, along the same lines, we did a survey in Orissa. This was also quite a few years back. We wanted to understand what factors drive recovery in fishing communities. Again, we found similar results, that apart from social and physical resilience, institutional trust, institutional resilience, governance, etc., are also very, very important in building adaptation. So, just like Dr. Soni, I would like to say that our current model is reactive adaptation. However, we need to have good risk assessment, and we need to prepare so that we have reduced losses and faster recovery. Right. So this kind of summarizes what I want to say, that of course the first step is we need to have integrated risk and vulnerability assessments. We need to have data on hazards, also on dynamic socioeconomic characteristics, so that we get to know every year which districts are most vulnerable, so that we can identify the gaps. We can have anticipatory adaptation options rather than being reactive. And this is the second part is reiterated many a times in all kinds of discussions that we have on adaptation, that we need to have integrated planning across vertically as well as horizontally, across different stakeholders as well as vertically. When I say vertical, it means multi-level governance. The state level has to be coordinated with the national level. The state level again has to be coordinated with the ground level, that is the district level perhaps, and the district level has to be coordinated with the community. And the learning has to be again circular. Learning doesn't stop at the national level, or learning that does not stop at the community level. The community has to learn how the higher levels of governance work, and the higher levels of governance has to learn from the community how they would like to have adaptation, or how would they like to be governed. So this will perhaps lead to reduce multi-hazard risk, but this is a very long way to go. It is easier said than done. We have been speaking about this since years on, probably since the time I was before I was born. So a lot of work to be done, but hopefully we can think of a brighter future. Yeah, that's all.
Thank you. Thank you so much, Dr. Malakar. If you could just unshare
Yes.
your presentation. I'll also request you if you could go into the Q&A box and answer a question by Sharanya, which is really
Okay.
on this question of what are the new sources of socioeconomic data. I know the data is an old problem, so I don't want to bring that into the discussion, but if you could just take a look. I'll turn to Dr. Johnson now. Dr. Johnson, I'm mindful that you have a hard stop at 5:30. So would you mind if I also brought in some of the questions into this round of conversation, or do you have prepared comments? Can you unmute yourself, please?
So whether we can trust, or what's the relevance of community science in a
Yeah,
climate
so there
where
are three interrelated questions. So one from Kimberly, which is talking about more, she's trying to draw attention to the ontological conceptualizations of the ocean, which communities that live on this interface has. And I think that's also what you were trying to say, that there's a lot more to the community knowledge than is usually perceived. And she's really talking about whether it is dismissed as myth, or, how do we really get this is a valuable source of data, and how do we really incorporate it? And of course, this question of the viability, when climate conditions are varying, how is this knowledge usable, and how does this actually respond? So if you could, in your comment, also sort of address a little bit these questions, and I give you the floor now.
Yeah, thanks. Thanks for those questions. I also relate to one of the comments made by Dr. Krishna. It's very important to circle learning. And in relation to that, I will also address one of the questions he actually found with coastal people in Tamil Nadu, also maybe other communities as well, why people don't trust the official early warning, for example. I will give that also. Okay, so let me start. Okay, so when people think about traditional knowledge or community knowledge, often they relate to the past because it's a traditional knowledge. Actually, that is not true when we work with the communities. Again, that's a land-based thinking. Ocean is a very dynamic process. The community is actually evolving with that dynamic process, especially practicing fishermen. They go to the sea. They cannot survive there with the fixed knowledge, fixed information. They have to adapt the situation emerge at the time. So that is what we need to see. See, the ocean is a dynamic entity. Therefore, the people who work with the ocean also, who engage with the ocean also, are very dynamic. Therefore, their knowledge is also very dynamic. That's one point I want to make. So it's not just a traditional thing. And the other aspect, how this community actually develop this knowledge, that's very important. How they develop, engage, build through the relationship. So this is actually, we are talking about a relational science. So relational science can be historical, of course it's a historical, traditional, but at the same time, they also apply this knowledge and they build a new knowledge, and apply that new knowledge and build new research, etc. They do. It's all these three processes actually happening together. If you work with the fishermen, if you understand how they take this knowledge forward. That's why it is very, very important, this community science and indigenous knowledge. And now we, for example, we work with our community and other communities as well. Through our Ocean Art School, we are documenting the traditional knowledge. So we are asking the fishermen to explain their stories. Again, that is why somebody mentioned about qualitative data. Yes, that's what I'm trying to talk about. So this qualitative data is very important. This is in stories, there is in narratives, experiences. So when we work with them, we ask them to just tell you a story. So then they are not telling the extract science. Mainstream science often is an extractivism. They do a lot of extractivism. You extract the data. Sometimes when you extract the data, you lose the holistic perspective. So that's why we just not ask them to extract the data. You just tell your story, your experience, what happened to you, how you are engaging with the ocean, etc. So what we found that very interesting, data, very rich data. We are trying to now make it accessible to the mainstream community and others also. So what we understood that this is actually indigenous science. It's not just traditional knowledge, it's actually the science. So the kind of relationship between the ocean and the people, that's where they argue. So if you are thinking about the multi-hazard approach or protection, but you also need to think about protection of the ocean as well. So protection of the ocean, protection of the people go together. I'm talking about indigenous perspective. That's one thing. The other, okay, so why people don't trust early warnings? Again, we did a project as part of Sussex University project, actually. We did a 4 years data. I did most of the ethnographic data collected from fishes in collaboration with many institutions, including INCOIS and also Husari University as well. So based on this research, fishers in general, they don't trust early warning. They don't trust. They have a reason for it. The reason is they are not reliable. That's the first thing. The official data, official information is not reliable. That's the number one. Number second, they are not accurate. Number third, they are not useful. So why I'm saying they are not reliable? Why not useful? Reliable in the sense, for example, when they give this data, the information, weather information, again, it is not accessible language. That is why one of the reasons it's not useful, because it's often given in English or some other languages, which is even not the coast dialect of our regional languages, for example. So that's why they understand the official version. That does not mean that they don't understand the science. There is a difference. We are talking about the language of the science, not the science itself. Okay, sometimes mainstream scientists make mistakes in that. So that's why it's not useful to them. The other sense is not useful to them. Again, we looked at the data, I think 2021-22, we looked at the monsoon data. So the early warning given by, I mean, that's the time, especially southwest coast of India, usually have very rough weather conditions. Like it's a long time, 2 to 4 months. So then they were giving one. We looked at 66 days of warning. Okay, continuously 66 days of warning they given by IMD. I mean, based on IMD, the Kerala State Disaster Management Authority give the information to the fishes. Out of the 66 days, only 3 or 4 days where the data were accurate, meaning they were predicting 45 kilometer wind speed, but actually the wind speed was less than 15 kilometers per hour. Okay, out of 64, only 3 or 4 days. Why the fishermen should trust that data? So it's obvious it's not 40 kilometer per hour. It's only 15 kilometers per hour. So that's the one thing. So why the mistake is happening? Because it is what we call over forecasting. Over forecasting in the sense you are giving a wider area. So meaning you are giving 300 kilometers of the area of distance you are giving information. That is your mathematical calculation. But fishes, they don't need that 300 kilometers area. They just need maybe 20 kilometers. What they want to know is, we are going to 20 kilometers distance from the shore to the sea. And maybe 20 kilometers, you can take the other side, north and or south. Then in this area, what will happen? It's a very practical question. That's what they want to know. But this information is not useful because this information may happen somewhere else, maybe 100 kilometers away, but they are not going 100 kilometers away for their fishing practices. That is why it's not useful. That is over forecasting. Then under forecasting also. Under forecasting, sometimes the weather is very high. I mean, the 60, for example, again, there is also a problem with, again, land-based thinking. Land-based thinking is the Kerala coast, Tamil Nadu coast. Okay, I mean there is no Kerala coast and Tamil Nadu coast in real sense. It's a coast, it's an ocean. You can say like Professor Bhati earlier mentioned, we can say ecosystem-based approach. That's fine, but there is no Kerala coast. You cannot separate Kerala coast and Tamil Nadu coast. Okay, so what they did, one cyclone warning they give. So they said there are no problems for Kerala fishermen. It's actually I forgot the name of the Fanny or the cyclone Fanny. No, some cyclone in 2021, I think May 27. I remember the date correctly. So they give this warning. So we were working with fishermen because they were following our localized weather information system. So then most of the fishers who followed our localized weather information in collaboration with CUSAT, they did not go for fishing. So those who followed official weather warning, they end up facing the high weather risk. I mean, the wind speed was 65 kilometers per hour. Because Trivandrum and Kanyakumari are closely connected. I mean, this is the same water. They share the same water. The impact actually up to, we calculate that day up to the Anjango region of Trivandrum. So it's all, I mean, under forecasting. So then 3 people killed. This is a real data. So why they should trust the data? There again, I mean, trust this official information. So what we found as a conclusion, the official warning, I'm talking about based on the data, may not be the same everywhere. Again, that's also need to understand. The official data, what we found that is either over forecasting or under forecasting, and also not sometimes, in many cases, may not be used. That is why they don't trust the official warning. So when they say this kilometer wind speed, it never happens. That's their experience. So that's where, again, qualitative data is very important. So again, the question earlier about can we, what's the relevance of this community science? Yes, it is relevant of community science. We are talking about ocean condition. So we are talking about a dynamic entity here. So therefore, it's very important. Then again, based on the community knowledge, so what we did was to make it sensible to you. So the Kusat University will provide 7 days forecast, 3 days forecast, and 1 day forecast. Okay. So then we asked the fishermen to test this forecast. So how it is useful, or whether it happened accordingly, etc., etc. So then based on the fishers' feedback, the modeling was actually improved. Then later we come to the conclusion that in 2022 is this paper also published by the scientists who worked in this data. So that there was 65 to 70% accuracy because of taking the feedback from the fishers. When we work with fishers, they are not against the science. What they are saying is we need more science. We need trustworthy science. We need useful science. That's what they are asking for. So when you want to provide that useful science, you need to work with community. So therefore, the community knowledge, accessible language and data, everyday experience are all matters.
Thank you, Johnson. That was, it all makes perfect sense, of course. But lots of questions in the Q&A box are also sort of, I guess reflecting these kind of frustrations of either the data not being adequate or updated enough or dynamic enough. And there's one question about, we will always be in this debate of we need better data, but what can we do with what we have right now, which I think may be pertinent for one of us to sort of respond to. And also, I think Harshvardhan's question to Professor Parth, Professor Roy, which is, his understanding, his takeaway was that socioeconomic and environmental aspects are currently not included in hazard estimations. Are they entirely quantitative right now? And this also relates, of course, to Dr. Malakar's sort of plead that we don't have updated data on some of these. So I think maybe if we could club and sort of each respond to the data related questions, which are mostly around what can we do with the data that we have currently? What can we do to bring in more of the non-quantitative data? And I think Johnson has already sort of given us a template of an experiment which was done in which community knowledge was integrated with scientific knowledge. If we could start with answering those. Johnson, do you have something to add right now? Maybe you can go.
Yeah, yes, that's why, before I leave, sorry for that. So Rudra's question about can localized forecast be integrated in forecast? Yes, we have been trying the last 3 years with the Kerala government, also with IMD, INCOIS, under the leadership of KUSAT, but it never materialized. They said, okay, we can integrate, we can also do for example, IMD said once, INCOIS also said one. We had a meeting, we have a multi-stakeholder meeting from the representative from the IMD, representative from the INCOIS, and there is a climate center in Kerala, and fisheries department, all people were there. They said, okay, this is very useful, we can do this integrated into main data, but never happened. So it's not, the scientists are ready to work, but the official system is not ready to take that forward. So that is the problem. It's a kind of, maybe, I don't know, personality issue, or maybe if the individual change, it might change, I don't know. But it's also something working together, no? That is missing here. So, but we have been trying. So we tried with the last government in Kerala. We also going to try with the new government as well. So when we try this, they talk about, okay, it's not the Kerala government should give weather information to the fishers. Again, we are not just asking for weather forecast. We are actually asking for weather information. meaning why weather information? You give the information to the people, let them take decisions according to their capacity, according to the place where they are going for fishing. If they go for only 5 kilometer distance, they may not need, the something happening far away from them. So they may not need, so that's how we need to, we were arguing for give weather information, let the fishers decide whether that information is how matched with their own fishing techniques. So when that is why there is a problem with early warning system. What according to fishers, what they need is not early warning. What they need is weather information. Again, localized. Again, depends on their needs and practice, capability, etc. A lot of again vulnerability, socioeconomic conditions also sometimes influence. If they need more money, for example, marriage or something, they do take risk. Even if they're higher weather condition, they may go fishing and do. So there will be an issue for that. So what we need is weather information. That weather information should be given accessible manner. Then let them decide whether they should go for or not. So
Yeah, we get that larger point of appropriateness of the scale and the kind of information, and how exactly this is to be dispersed, and to actually hear the feedback of what is actually needed on the ground. Dr. Malakar, you've had your hand up for a while. Did you want to interject
Yeah.
this
So
conversation?
yes, I think Dr. Jemit will leave very soon, so I wanted to follow up on his point. Thank you, Dr. Jemit, for your insights on early warning systems, and I completely agree with them. Actually, we had the same observations in our field work following that work, so I didn't have much time to, go in depth. Why people don't trust these early warning systems. We had the same observations. They mostly over forecast. I mean, they would say that don't go out in the sea today, and then they will lose their day's wage on that day. And most of the time, these warnings again are not does not come out to be true. So there are issues. There are these issues, and I have observed them both on the west coast and the east coast. So I have done field work in Maharashtra as well as in Tamil Nadu, and people have same observations. But my Maharashtra fieldwork was around maybe 7 to 8 years back, but I have seen that EWS systems have improved, so we have to give scientists also some buffer time where they are improving systems. Things are becoming more accessible. There has always been talks of implementing community knowledge to these apps, and actually in Tamil Nadu people have started implementing, but of course they are not to the extent that fishermen are expecting the knowledge to be the scientific knowledge to be translated to community knowledge. So that's what I wanted to add, that we have the same observations, so it's nothing different. I just couldn't go into in depth why people don't trust. I'm just saying that to build adaptive capacity, we need to build trust of people on these scientific systems, on the governance systems. So for that, we have to dig deeper why we are not trusting right now. Of course, there are issues, so we need to figure them out. Right. Thanks.
Thank you. Can I turn to Professor Roy, please? I mean, there are questions directly about the data and what we can do with what we have, and what is exactly the kind of interconnections we need in the data itself.
Great. I think my task is made quite simple. I will go with the two panelists which has concluded that people do not trust the data. Yes, to great extent, this is every sphere of the coastal zone management. The weather information, forecasting, the early warning system, the data set which is generated for the vulnerability, the risk assessment. But the common point is, are we having a minimum level of required data set which is to give a reliable data to the local people or for the purpose. So first thing, if you come to land based, you do not have appropriate scale or repeat cycle. The granularity of the data which is available is very poor, and that does not address a very detailed and complex landscape in the coastal region. We need, second thing is, these data sets are, served 10 to 15 year cycle, and 10 to 15 year cycle is a very, very coarse temporal domain. These data sets are not relatable on the ground, because land systems in the coastal zone has become very, very dynamic. Coming to the socio-economic data, we, as Krishna has worked with the 2011 data. After 2011, we do not have any uh, census data. The population data is very, very poor. At the moment, we don't have. Coming to the communities informations also, we do not have any mechanism. We should take leverage from the current technological advancements, wherein the many of the practices have been improved with the citizen science program, building a data sets coming from the citizens on the community issues of the data set, and they also contribute the data sets on through citizen science network. Of course, the data processing of the citizen science data will be different. Coming to the weather related information, uh, the again the IMD and the forecast is supposed to be given by IMD. Basic research and improved models exist elsewhere in the research institutions. IMD worked in something like secondary level of information, which is used for prediction. IITM produces high level of accurate data, but they remain an experimental domain. IMD in operational domain. These predictions do not work together. I have seen this, all the coastal zone hazard mapping, these kind of data sets are not properly incorporated. Lastly, I would suggest a kind of a coastal resilience observatories, which are basically uh, specific issues like West Bengal and Eastern Coast and Odisha, similar kind of issues. Maybe then Andhra Pradesh is a one block. Then if you decentralize issue-wise observatories, devise a federated structure and contribution from uh, the citizen science program, bring in data set which is appropriate and you can use in the current contemporary tools which are available, especially geo AI tools, which are using probabilistic parameters, where creating a scenario on a creeping issues. So that will be much more reliable, and people will be trusting more such kind of a data set. Lastly, I would say that the today the one thing is very clear, that we have been able to save the lives of people. The life of the coastal zone has been saved considerably. We do not have the that much kind of a loss of life. But what we have not been able to address today is the damage to the different ecosystem and degradation of the ecosystems in the coastal landscape. Finally, I will end with a kind of a recommendation. This geospatial intelligence must be embedded in a kind of a institutional mandate, which makes them compliant to share the information which are social relevant. At the moment, people do not share complete information, and that inhibits planning and especially appraisal, implementation, and monitoring. Monitoring mechanism cannot be done because appropriate data sets are not available. Granularity of the data is very poor. Thank you.
Thank you. You've preempted my final round of questions, sir, and already given your recommendations. But let me also sort of go to both Johnson and Dr. Malakar. Just succinctly, since we are talking about strengthening coastal resilience, and there are a few unanswered questions, but we've sort of skirted around them. So I'm going to leave them there for now and try and wrap up very succinctly. Since we are focusing on coastal resilience, if you were to recommend one governance reform or one institutional action that could help, like right now, what would that be? Dr. Malakar? Sir's already done his job, so it's up to you.
Thank you.
So I would reiterate whatever I have told throughout this webinar, that it's not
I'm
an
asking
easy
you to
task.
pick one. You'll have to think like a bureaucrat for a second and not like an academic, just for a second. If you had all the resources and everything in the world, what's the one thing that you would really focus on or prioritize?
And adapt. You are asking about adaptation strategy, or
Yeah.
how things should be governed. So I think adaptation problem is mainly a developmental problem. We have been talking about capability approach development since the 1970s, 80s. We have just renamed it as adaptation because now we are talking about climate change. Climate change is the inward, right? I'm not saying that it is unnecessarily an inward, it is the need of the hour. So if we focus on good developmental trajectories, then we can address climate change. And for this, like as usual, in the 90s and 80s, people talked about poverty. All the departments should be coming together, all government verticals should be coming together to remove poverty, to remove this to improve health, to improve access to education. So I think we don't have to go afar from these objectives. We have to follow the same objectives. It's just that right now we have to also consider future climate change scenarios. That's it.
Thank you. Thank you. Great answer. Johnson, any last recommendations?
Yeah, I think I
If you
want
had
to.
one magic card, then what would the magic
Yes,
card be?
I want to. I want to say this point, which also may address to one of the questions asked by Josna in the Q&A. So because there is a accelerating this coastal infrastructure development, no? So that's also you need to
The
understand.
tension between coastal resilience and development and infrastructure.
Yes, that also needs to. So for that, I have this point. Implement a PIC. A PIC means free, prior, and informed consent. So meaning free means decisions are made without coercion or intimidation when you work with these communities. Prior means you have to start engaging in the community. They have knowledge, they have traditions, identity, etc., etc. So that will actually give you new direction, new perspectives, and also even new innovations. So informed means host communities should receive a complete, accurate, culturally appropriate, and understandable information about the potential benefits, risk, alternatives, whatever projects come to the coastal area. So consent means coastal, especially coastal indigenous people, have the right to give or withhold their consent through their own representative institutions, their own customary law systems, their own decision-making process. That's what I want to say. Thank you.
Great. Thank you so much. Before I formally thank everyone for being here and 55 people for still sticking around, Sony, do you have any sort of final comments since it's your work that has brought us together here?
Thank you, Mukta. And I think just one point, I'm very happy to listen to multiple comments and questions and also great points made by the panelists. So a lot of points about data, trust, community science, and so on. And I just wanted to mention here that, that is the kind of way forward we are thinking of. Now we'll be going more deeper. What the issue brief we put out is a kind of very higher level analysis at the national scale, and we did not go to the subnational. But now we are going more deeper with multiple data sets at the documents level, policy documents, plans and level. But we call it as a network of plan analysis, and then we would also engaging with the government at the different levels. So somebody also, I think Dr. Malakar mentioned about multi-level governance, and that's what we are trying to understand how we can ensure horizontal and vertical, kind of coordination. And very happy that all of you have joined, and please feel free to write to us and give more comments, and then we will reach back to you. Thank you so much. I'll stop there.
Thank you, Sony. And with that, we've wrapped up in time because we had these amazing panelists who were so alert and an extremely engaged audience, which asked lots of questions. So glad and thank you very much for spending your precious Thursday late afternoon with us. Thank you, Professor Roy, Dr. Malakar, and Johnson, who's just left. And thank you, Sony, for for putting us together today. And thank you everyone who is still here listening to us, and we'll hope that you come back to future webinars, which we hope to have in the near future.
Thank you. Thank you all for the
Thank you.
invitation.
Thank you. Thank
Bye.
you.